Intermediate Algebra for Statistics. Finding Linear Models Part 2. Lesson Objective. Find the equation of a linear model by using data described in a table. Lesson Objective. Finding the equation of a linear model. To find the equation of a linear model, given some data, number 1, create a scattergram, or sometimes known as a scatter plot of the data. Determine whether there is a line that comes close to the data points, or in other words, we want to see, does the data suggest a linear pattern? Number 3, find the line of best fit. This is also known as the linear regression line, using a graphing calculator. Number 4, use a graphing calculator to verify that the line of best fit comes close to the points of the scattergram. Let's do an example. Example 2. The average SAT math scores of college-bound high school seniors are shown for various years. Let S be the average SAT math score and points at T years since 1980. Find the equation of the line that comes close to the points in the scattergram of the data. Use this model to predict the average SAT score for 2010. So here's the scattergram. We can see that the blue line is a good model for these data points, and the data points do have a linear pattern. The red line, even though it's going through 2 actual data points, this is not a good model for this data. So using the graphing calculator, we want to hit the Stat button, then hit Enter for Edit. In List 1, we put the independent variable, which is the number of years since 1980. And then in List 2, we put the dependent variable, which is SAT math scores. Then we hit second y equals, which is stat plot. We hit Enter. We make sure that the plot is on, that is on the scatter plot. List 1 is our X list, that's correct. List 2 is the Y list, that's correct. Then we hit the blue zoom button and scroll down to number 9 where it says zoom stat. And here we have our scatter plot. This looks like a linear pattern. Next we hit the stat button again. Use the right arrow key to go to calculate, and then we want to choose number 4, which is linear regression, and this is the line of best fit. A is the slope, 1.08 if we round to 2 decimal places, and B is the y-intercept, which is 491.72 rounded to 2 decimal places. Now we hit the y equals. We type in the equation 1.08x plus 491.72. We hit graph, and we can see that this line of best fit is fitting the data well. If we hit second and graph, which is our table feature, we can scroll to when x is 30, or we could just type in 30 here and hit enter, and we see that the predicted y value is 524.12. So we would say, according to the model, in the year 2010, and that's when t is equal to 30, the predicted average SAT math score is 524.1, rounded to 1 decimal place. Example 3. According to a poll performed by the National Consumers League. People are more concerned about privacy issues than about healthcare, education, crime, or taxes. The percentage of Americans from various age groups who consider their home address to be personal information are listed in the table on the next slide. Let P be the percentage of Americans at age A years who consider their home address to be personal information. Find the equation that models the data well. Use the model to predict the percent when the age is 65. So we have our data here. So these are the various age groups. So this is 18 to 24 years of age, 25 to 34, 35 to 44, so on and so on. Because this is an interval of numbers, we're going to use what's called the midpoint to represent this interval of ages. So for 18 to 24, we're going to use 21. For 25 to 34, we're going to use 29.5. So this will be our independent variable. The percent is our dependent variable. So here's the scatter plot. We see that the data points do have a linear pattern. Using our graph and calculator, we hit the stat button and then enter. We input our independent in list 1, the dependent in list 2. Next, we hit our stat key, right arrow to calculate, and then we want number 4, linear regression. Hit enter. This pastes this to the home screen. We hit enter again, and this is our line of best fit. The slope is a negative 0.43, and the y-intercept is 92.85 to 2 decimal places. Now we hit our y equals. We want to type this equation in so we can see how well does this line of best fit our scatter plot. So next we hit zoom, then number 9 for zoom stat, and we can see the line of best fit with our scatter plot. This line is fitting the data well. So using the table feature, we want to predict when the age is 65. So we can type in 65 and hit enter, and we see that the corresponding y is 64.9. So for this problem we would say, according to the model, the percent who consider their home address to be personal information is 64.9% when the age is 65. Thanks for watching.